Hello everyone. Today we will be looking at some of geometry questions and concepts. So let's start off with the part one of that series. The part one of that series is called lines and angles. So let's look at what it what it includes. So while starting with lines and angles, I am assuming that you already know about what is a line, what is a line segment, ray, what are angles, acute angle, obtuse angle. So I'm leaving those parts and starting off with supplementary angles, right? Supplementary angles, for example, if we are seeing in this figure, this one, angle AOC plus angle COB is equal to 180 degree. So this pair of angle, which is AOC and COB, is called 180 degree. So so what we can conclude from this, that a pair of adjacent angles whose sum is a straight angle is called a linear pair, and also it is equal to 180 degree, right? If the sum of two angles is 180 degree, then the angles are called supplementary angles, right? Then what is a complementary angle? If sum of two angles is 90 degree, then the two angles are called complementary angles. So as you can see in this example, COA plus AOB is 90 degree. So this is a complementary angle. Okay. Let's move to the next slide. And after each video, we'll be solving some questions based on the concepts that we'll be learning in these videos. So be very attentive while I'm discussing the concepts, right? Adjacent angles. So what are called adjacent angles? The angles that have a common arc and a common vertex are called adjacent angles. So in this example, this OA, this OA is a common arc between this angle and this angle, right? And O is a common vertex. So when I say angle AOC and angle AOC and angle BOA, you can see OA is a common arc in both these angles, right? And O is a common vertex. O is a common vertex. So we can say that angle BOA and angle AOC are adjacent angles, right? Adjacent angles means nothing but two angles which are having a common arc and a common vertex. Okay. So what is a vertically opposite angle? Vertically opposite angles are when two lines intersect each other. When two lines intersect each other, they form such a this kind of figure. You can also see it here. So when I say this angle, and the vertically opposite angle of this angle is this one, right? So the angle formed opposite to each other at the point of intersection, also known as the vertex, are called vertically opposite angle, right? And it is also a property that these vertically opposite angles are equal. This is also a very important property which we will be using in while solving a lot of questions, right? So this is a very important property, that vertically opposite angles are equal, right? So this one is equal to this one, and this angle is equal to this angle, right? So in the figure above, X and Y are two intersecting lines, right? A and C make one pair of vertically opposite angles, A and C, and B and D make another pair, and these pairs are also equal in nature, right? So angle A is equal to angle C and angle B is equal to angle D. Perpendicular lines, I hope you already know what a perpendicular line is. Perpendicular line is any line which makes a 90 degree with the intersecting line, right? When there is a right angle between two lines, the lines are said to be perpendicular to each other, and they make a 90 degree, right? Parallel lines, right? So let's look at some of the properties and some of the angles which forms in case of parallel lines. Okay, so when two parallel lines here A and B, when they are intersected by another line P, which is also called as transversal, uh, 8 angles are formed, like 1, 2, 3, 4, 5, 6 and 7 and 8, right? So what are the properties? The corresponding angles are equal. So which of these angles are corresponding in nature? So angle 2 is corresponding to angle 6. So these two angles are equal. Similarly, angle 1 and angle 5 are corresponding. So these two are equal. Angle 3, angle 7 are equal. Angle 4 and angle 8 are equal. Right? Apart from this, the vertically opposite angles are equal in nature. Vertically opposite angles you already know. So I hope you can see the vertically opposite angles here. Angle 2 and angle 4 are vertically opposite in nature and hence these two are equal. Similarly, angle 1 and 3. Similarly, angle 1 and 3. And on the line B, angle 6 and angle 8 are equal, and 5 and 7 are equal in nature. Alright. The alternate interior angles are equal. The alternate interior angles are those angles which forms a Z. Right? So let's see what are the angles which forms a Z. So when I say Z, it can be an inverse Z as well, right? So when you see this angle 3 and angle 5, you see the parallel line along with the transversal makes a Z, right? So these two angles are called alternate interior angles. And similarly, so angle 3 is equal to angle 5. Angle 3 is equal to angle 5. Similarly, angle 4 is equal to angle 6. Similarly, angle 4 is equal to angle 6. Right, this is angle 6. This is angle 4. These two are also equal. Alternate interior angle 4 is equal to angle 6. Okay. Let's read the other property. The alternate exterior angles are equal. So the alternate exterior angle will be this angle 2 and angle 8. These two will also be equal. These are alternate but exterior. These are on the exterior side of the line. So these are alternate exterior angles. Angle 2 will be equal to angle 8 as per property 4. Angle 2 is equal to angle 8. Angle 2 is equal to angle 8 and angle 1 is equal to angle 7. Angle 1 is equal to angle 7. Okay. So let's look at the final property of parallel lines in the transversal. The pair of interior angles on the same side of the transversal is supplementary. Okay. Let's understand what it wants to say. This saying here, you already know the meaning of supplementary. Sum of two angles when it is equal to 180 degree, it forms a supplementary angle, right? The pair of interior angles in the same side of transversal is supplementary. So on the same side of transversal, the interior angle. So for example, angle 3 and angle 6, these two forms a supplementary angle. And similarly, angle 4 and angle 5. So you can say that angle 3 plus angle 6 Angle 3 plus angle 6 is equal to 180 degrees, right? Is equal to 180 degree. And similarly, angle 4 and angle 5 is also equal to 180 degrees. So while solving any question on parallel lines, right, you must remember these properties to get your answer. And also sometimes these properties are used in questions of circles when there are chords which are parallel to each other, right? And in case of rectangle, quadrilateral, and many more areas. So it is very necessary to learn these properties through heart, right? So let's look at some of the questions based on these properties. I hope these points are clear to everyone. Okay, here the question number one. Question number one says if lines M and N are parallel to each other, then determine the angle 5. This is angle 5 and angle 7. And given is angle 2 is 125 degree. Okay, 125 degree. So by linear pair property, we already know the value of this angle, right? This is how much? 180 minus 125. 180 minus 125 is how much? 55 degrees. 55. So if this angle is 55, this angle will also be 55 degrees. Why? Because it is a corresponding angle, and we know that corresponding angles are equal. So angle 7, the value of angle 7 is 55 degrees. Angle 7 is equal to 55 degrees. Right. What about angle 5? Angle 5 is vertically opposite to angle 7, and we know that vertically opposite angles are equal. So angle 5 will also be equal to 55 degrees. Right. So angle 5 and angle 7 both are equal to 55 degrees. So let's look at the second question. Okay. Here it is given that angle A is equal to 120 degree and angle H is equal to 160 degree. So we need to find if these two lines are parallel in nature or not, right? So if our properties are satisfied, then we can also say that these two lines are equal in nature, right? If so, the thing is like this, that if two lines are parallel in nature, those properties must be followed, and if any two lines with a transversal are following those properties, we can say that these two lines are parallel in nature. So here we are going to see whether those properties are true or not in this case. So angle A is 120. Angle A is 120. So angle D will be how much? Angle D will be 60 degree. By linear pair, angle D will be 60 degree, right? And by the use of corresponding angle, we can say angle H must be equal to angle D, which is true here, because angle H is 60 degree given. So we can say that these two lines are parallel in nature, parallel, right? So these two lines are parallel in nature. How we concluded that? Corresponding angles are equal, right? Let's look at the third question and the last one of this series. After that, we will discuss some other topic of geometry. If P and Q are two lines parallel to each other and angle E is equal to 50 degree, angle E, this angle is 50 degree, then find all the angles below. Alright, this is 50 degree, we know this. If this is 50, this will also be 50 corresponding angle, right? This is 50. If this is 50, this will be 130 linear pair. This is 130. If this is 130, then this will be 50, as these two are vertically opposite angles, right? This is 50, this is 50, this will be how much? This will be 130. Corresponding interior angles are supplementary in nature, and also it forms a linear pair. So anyway you can find the value of angle F, then this angle will be 50 degrees vertically opposite to angle E, and this will be 130 vertically opposite to angle F. Right? We know the value of this angle corresponding angles property. If this is 130, this will also be 130. Right, this will also be 130. And this is 90. Here it is given that this is 90 degree. So the value of angle O will be how much? 130 minus 90, this is 40. Right? This will be 40 and this will be 90 and total will be 130. So we have been able to find the values of each and every angle. So with this we conclude lines and angles. In the next topic, in the next series of this videos lecture, we'll look at triangles and its properties and we'll again solve some questions. Thank you. This is the second part of the geometry series. In this part, we will be looking at the properties of a triangle and some questions based on these properties. So let's start. Alright, so here we can see there are some properties for a triangle. The first property says sum of any two sides of a triangle is always greater than the third side. That is, A plus B must be greater than C, B plus C must be greater than A, and similarly C plus A should be greater than B. And the side opposite to angle A is called side A. The side opposite to the angle B is called side B, and the side opposite to angle C is C. Right? So these A plus B are sides A and B. Right? The second property says the absolute difference of any two sides of a triangle. Any two sides of a triangle is always less than the third side. So if we take difference of any two sides, suppose C and A, it must be smaller than the third side. And similarly, it is valid for all the three sides. Right? That is, A must be greater than B minus C, B must be greater than C minus A, and similarly C must be greater than A minus B. Right? The third property, side opposite to the greatest angle will be the greatest. and the side opposite to the smallest angle, the smallest. Right? Side opposite to the smallest angle is the smallest. So in case of obtuse angle, you see, in case of obtuse angle, if suppose this is A, this is B, and this is C. This is the largest angle, this is the largest angle, and the side opposite to this one, AC, is the largest side. So this is what the property here says, that side opposite to the greatest angle will be the greatest, and side opposite to the smallest angle, if suppose this is the smallest angle, then BC will be the smallest side. Okay? This will be the smallest side. Property number 4 is also known as the sine rule, and it states that A upon sine of angle A is equal to B upon sine of angle B is equal to C upon sine of angle C, and these three ratios are also equal to twice the circumradius. Circumradius is nothing but the circle which circumscribes a triangle. Okay? Circumscribes a triangle. So this circle which is circumscribing this triangle is called circumcircle. This is a circumcircle, right? Circumcircle. This is circumcircle, right? And suppose if this is the center of the circle, this radius, this will be called circumradius, represented by capital R. Right? This is capital R. And these A, B, and C, these small A, B, C are the sides of the triangle, and these A, B, C are the angles. Okay. The fifth property is also known as the cosine rule, and it states that A square is equal to B square plus C square minus 2BC cos A, and this is valid for every side and all the corresponding angles, right? A square is equal to B square plus C square minus 2BC cos A, and similarly for B you can write it as B square is equal to A square plus C square minus 2AC cos B. And similarly for C as well, right? So this is known as cosine rule. And the last property is the exterior angle is equal to the sum of two interior angles not adjacent to it, right? So in this figure you can see the angle 4 is an exterior angle. Angle 4 is an exterior angle as it lies outside the triangle and on this line, right? On line AB and outside the triangle. So this is an exterior angle, and it says the exterior angle is equal to the sum of the two interior angles not adjacent to it. So adjacent to this one is this. So angle 4 is equal to sum of angle 2 plus 3. Angle 4 is equal to angle 2 plus angle 3. So this is known as external angle property. Right. So if we are given three sides of a triangle, then all the above conditions must be followed for the triangle to be possible. However, rather than checking all the conditions, Even if we check any one of the conditions, most preferably if we see that the first property is being satisfied by any triangle, then the triangle is a possible one, and we need not check every other property, right? So let's look at some questions based on these properties. Okay. Question number one. Question number one says, how many non-congruent triangles are possible such that their sides are integers and perimeter is equal to 40. Okay. So A plus B plus C is equal to 14. This is given. This is perimeter. A plus B plus C is 14. Okay. So let's assume that C is the largest side. Let's assume that C is the largest side. So what can be the value of C? What can be the largest possible value of C? If we can take C as 7, if we can take C as 7, then A plus B must also be equal to 7, which does not satisfy the first condition, which is sum of two sides must be greater than the third one. So this 7 value for C is not possible. So the largest value that C can take must be 6. Must be how much? Must be 6. Right? Because then only A plus B will be equal to 8, which is greater than C. Okay? So the largest possible value for C is 6. And in that case, A plus B will be equal to how much? 8? 8. So for 8, we can have various options: 4 plus 4, 5 plus 3, 5 plus 3, 6 plus 2, right? These three possibilities are there, right? What if the value of C is less than 6? Suppose 5, and 5 is the largest side, then A plus B will be how much? If this is 5, this will be 9, right? And for A plus B to be 9, there is only one possibility, which is 5 plus 4, right? We cannot take 6 plus 3 because the largest side is itself 5, so we cannot have 6. So 5 plus 4. So these are the only 4 possibilities which satisfies this condition, and also it is a possible triangle, right? So the answer to this question is 4. I hope this is clear to everyone. I hope this is clear. We have used the property number 1 here and solved this question. Also, apart from this basic method, we can also use a shortcut method here. There is also a shortcut method which states that if the value of the perimeter, suppose n represents the perimeter, and if value of perimeter is even, right? The value of perimeter is even, then the number of non-congruent triangles is equal to n square by 48, right? N square by 48, right? And if this n is not odd, not even, if it is odd, then number of triangles non-congruent triangles will be equal to n plus 3 whole square upon 48. Also, it is very important to keep in mind that these brackets does not represent the greatest integer function. These brackets does not represent greatest integer function. It basically means the nearest integer value, right? The nearest integer value possible will be the answer, right? So in this case, n is 14, so it is even, so we'll be using this formula. So 14 square is how much? 196, right? 196 upon 48, 196 upon 48 is somewhat equal to 4.1 something, 4.1 something, right? So it is closest to 4, hence the answer to this question is 4. Suppose if the value will be somewhat 4.7 or 4.8, then the answer could have been 5, right? But here the answer will be 4. So either way you can solve this question, right? So after this, let's look at the second question. The second question here says, consider an obtuse triangle with sides 8, 15 and x. One side is 8, other side is 15, and the last side is x. We don't know the value of x here, but we do know that x is an integer, right? The question says, how many such triangles are possible? How many such triangles are possible? Okay. For any triangle to be possible, there are certain properties that a triangle must follow, which is sum of two sides must be greater than the third side. So 8 plus 15 must be greater than x. 8 plus 15 must be greater than x, and 8 plus 15 must be greater than x, and similarly 8 plus x should also be greater than 15. Sum of two sides must be greater than the third side, right? So from here we can find out the range in which the value of x lies, right? X is smaller than 23 from first equation. From equation 1, we can say that x is smaller than 23. And from the second equation, we can say that x is greater than 15 minus 8, which is 7. Right? So the range of values, the x lies from 8 to 22, right? Okay. So we know the value of x, right? In which range it lies. So in this range, it is possible that those triangles could be acute angle also. It could be a right angle also. But we need the number of obtuse triangles, right? And it is and there is also a very important property which only obtuse angle triangles follow, which is c square. C square is equal to, c square is not equal to, c square is more than, c square is greater than a square plus b square. A square plus b square. So this is a property which all the obtuse angle triangles follow. And here C is not just any side, C is the largest side. So if this is a obtuse triangle. This is C, this is A, this is B, and C square will always be greater than A square plus B square. And we know for a right angle triangle this C square value is equal to A square plus B square. This is also known as the Pythagoras theorem. So these are the properties which differentiate between these three types of triangles. This is for right angle triangle, and for acute angle triangle, C square is less than A square plus B square. So this is also a very important property, and I say you must note it down, because these properties can be useful in a variety of questions based on triangles. Right? Here we are going to use this property, which is valid only for obtuse angle triangles. Right? C square is greater than A square plus B square. C square is greater than A square plus B square. So, what if the value of the largest side is x, then x square must be greater than how much? 8 square plus 15 square. 8 square plus 15 square. 8 square is 64, 15 square is 225, 64 plus 225 is 289, which is 17 square. So x must be greater than 17. X must be greater than 17. Right? What if the largest value of the largest side possible is 50? In that case, 15 square must be greater than 8 square plus x square. 8 square plus x square. So from here you can find out the value of x. 15 square is 225. 225 minus 64 is 161. So x square is smaller than 161. So the largest possible value of x is 12, because 13 square is 169. Right? So x is smaller than 30. X is smaller than 30. So the value of x to 12 is possible. So from 7 to 12, from 7 to 13, and from 17 to 23, all the possible values of x are there, right? So from the value of x lies from 8 to 12, and 18 to 22. 18 to 22. So from 8 to 12 there are 5 values, and from 18 to 22 yet again there are 5 values. So total there are 10 possible values of x for which the triangle will be a obtuse triangle. So the answer to this question is 10. Let's look at the last question of this video. ABC has three integers. ABC has integer sides x, y, and z such that x z is equal to 12. How many such triangles are possible? You know the value of x into z. X into z, which is 12. Right? Here x, y, and z. Right? What could be the possible values? 1 and 12. Right? 1 and 12. In that case, the value of y could be 12, as it satisfies the condition that sum of two sides is more than the third side. Right? Can it be any other number? Suppose if this is 11, if y is 11, this is not 4, this is 11. If y is 11, then sum of two sides will not be equal to, will not be more than the third side. So value of y as 11 is not possible. What if the value of y is 30? Then again, sum of two sides is not greater than the third side. So this value is also not possible. So only one possible value is 12, right? Okay. When this is 2 and this is 6, this also makes the product as 12. Okay. So what can be the values here? 2, 6, 6. Right? Can the value of y be 5? 5? Yes, it can be true, because sum of two sides is again greater than the third side. 2 plus 5 is 7 and is greater than 6. So 2, 5, 6 is also possible. What if the value of y is 4? This is not possible because x plus y will be equal to z and not be greater than z. So 2 plus 4 is equal to 6, not greater than 6. So 4 is not possible. Right? And any number less than 4 is also not possible. What if the value of y is 7? If the value of y is 7, 2 plus 7 is 9, which is greater than 6. 6 plus 7 is 13, greater than 2. So it is also possible. What about 8? 2 plus 8 is 10, greater than 6, but 6 plus 2 is equal to 8. So 8 is not possible. So three possibilities are there when 2 and 6. 2 and 6 is there. So till now there are how much possibilities? 1, 12, 12, 1, 12, 12, 2, 7, 6, 2, 6, 6, 2, 5, 6. Right? This is why. What if we break the product as 3, 4? If we break the product as 3, 4, then 3, 4, 4 is possible as sum of two sides is greater than the third side, right? What if we take the value of y as 3, then again sum of two sides is greater than the third side. 3 plus 3 is 6, which is more than 4. 4 plus 3 is 7, which is more than 3. So 3 is also possible. What if we take the value as 2? 3 plus 2 is 5, which is more than 4. 4 plus 2 is 6, which is more than 3. Then 2 is also possible. Is 1 possible? No, 1 is not possible. Why? Because 3 plus 1 is equal to 4 and not greater than 4. So 1 is not possible. Let's look at values which are more than 4. What about 5? 3 plus 5 is more than 4. Yes. 4 plus 5 is more than 3. So it is also possible. What about 6? 3 plus 6 is 9, more than 4. 4 plus 6 is 10, which is also more than 3. So 6 is also possible. What about 7? 7 is not possible because 3 plus 4 is 7, which is equal to this value, and therefore this is not possible, and any number beyond 7 is also not possible. So what are the values which are possible? 1, 2, 3, 4, 5. So these are the 5 possibilities when the product is 3, when the product is distributed as 3 into 4, right? So the total number of possibilities are 1, 2, 3, 4 and 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are 9 possibilities, right? So 9 is the correct answer here, right? Okay. So moving on to the next video series of this lecture. So this is the third part of the video series in which we are covering the geometry section. So in this third part we are going to look at the area of a triangle, and we'll also solve some questions based on the things that we'll be learning in this series, right? So let's start. Okay, area of a triangle. So area of a triangle, there are multiple formulas in which we can find. So as per the given question and as per the given input, we'll be using our formula, right? So area of a triangle can be found out by using half base into height, right? It is also it can be also found out by using the Heron's formula, which is this root under s into s minus a, s minus b into s minus c, and this s is nothing but the semi-perimeter of the rectangle, semi-perimeter of the rectangle, sorry, triangle, right? S minus c. And this s is equal to a plus b plus c by 2, where a, b and c are the sides of the triangle. Okay. Alright, so the third formula for finding out a triangle, the area of a triangle, is r into s, where r is the in radius. Okay, in radius is the radius of that circle which is inscribed in that triangle, right? Inscribed in that triangle. Inscribed means a circle which is touching all the three sides, and it is lying inside the triangle. So this is in circle, and this radius is called in radius, small r, right? Another formula for finding out the area is half into product of two sides into sine of the included angle. Suppose if I know the value of this side, which is C, and this side, which is A, and I know the value of this angle, and if I know the value of this angle, then I'll be able to find out the area by using half AC into sine of angle B, sine of angle B. So this is the included area, these are the two sides, right? And it is also true for other sides as well, right? And finally, one more formula for finding out area is ABC upon 4r, where this r is the circumradius. Here we found out the in radius, the circumradius is the radius of the circumscribing circle, right? And it is denoted by capital R. The radius of that circle is represented by capital R. So the radius of this circle is called circumradius, denoted by capital R. Okay. And ABC are the sides of the triangle. Okay. So let's look at some problems to understand these formulas in a better way. Okay, the first question here says sides of a triangle are 6, 10 and x. One side is not known. What is the maximum possible area of the triangle? Okay, the maximum possible area of the triangle will be half into 6 into 10 into sine of the included angle, sine of the included angle. Suppose that angle is A, then sine of A, right? Sine of A. The maximum value of this angle, the maximum value of sine A is 1. We know the maximum value that sine A can obtain is 1. So we are going to take it as 1, and the answer to this question will be 30. Right? 30 is the correct answer. Let's move to the second question. Okay, here the question says there is an equilateral triangle with a square inscribed inside it. Okay, one of the sides lies on the side of the equilateral triangle. What is the ratio of area of the square to that of the equilateral triangle? All right. So here there is an equilateral triangle and a square is inscribed inside it, and one of the sides of the square lies on the equilateral triangle. So this is the side. Suppose this side of the square is A, right? Side of the square is A. We need to find out this area of this square and the area of this equilateral triangle, and then take the ratio to get to our answer. Okay, so suppose this is A, this is B, this is C, this is D, E, F, and this is G, right? This is G. So in area in triangle ADE, in triangle ADE, in triangle ADE, in triangle ADE, angle A is 60 degree, angle A is 60 degree, right? Angle A is 60 degree. ED is equal to A, ED is equal to A, which is the side of the area. ED is equal to A, ED is equal to A. Angle A is 60. Angle A is equal to 60. So applying tan A will be how much? Tan A is equal to ED by AD, right? Tan A is how much? ED upon AD. ED upon AD. We know the value of ED, which is A by AD. Right. Tan A is tan 60. Tan 60 is equal to root 3. Root 3. Therefore, AD, the value of AD is A by root 3.
Hello Ramana, good morning.
A upon root 3.
Chappan Ramana.
Right. Similarly, GC is also A by root 3.
అంటే ఏమని చెప్పాలి అక్కడ పోయి
right? This is also a by root 3.
ఓకే గ్యాప్ స్టెప్ అట్లా ఇచ్చిన పేరు చెప్తే సరిపోతుందా
Therefore, the side of
ఓకే అండి ఓకే
the equilateral triangle is equal to a plus 2a by root 3, right? 2a by root 3. This is the side of the equilateral triangle. Let's simplify this. We can write it as root 3a root 3 plus 2 upon root 3a. This is the side of equilateral triangle, right? This is the side of equilateral triangle. Okay, and we need to find out the ratio of the two areas, right? And obviously we need to keep the area of square as numerator. Okay, this is root 3. Area of triangle. Let's find out the area of the equilateral triangle. Area of the equilateral triangle will be how much? Root 3 by 4. This is also a very important formula for finding out the area of an equilateral triangle. Root 3 by 4 into side square to side square. Here that side is root 3 plus 2 upon root 3a. So root 3 by 4 and square of this is how much? Square of this is 7 plus 4 root 3 by 3 a square, right? Okay, so this is the area of the equilateral triangle. Area of square will be how much? A square. So a square upon this. So this 12 will go to the numerator, right? This 12 will go to the numerator. A square gets cancelled. A square cancel each other. So 12 upon 7 root 3 plus 12. So 12 upon 12 plus 7 root 3. This is the correct answer, right? This is the correct answer. Let's look at the next question. I hope the previous question is clear to everyone. Let's look at the next question. Here the question says, consider a right angle triangle. Okay, so there is a right angle triangle with in radius 2 centimeter. So by this I hope you already know what is an in radius. It is a radius of the in circle, right? In radius, and we represent in radius by small r. In radius is how much? 2 centimeter, right? And the circumradius is 7 centimeter. Circumradius is 7 centimeter. Okay. So in case of a right angle triangle, the circumradius lies on the hypotenuse. The center of the circumcircle in case of a right angle triangle lies on the hypotenuse, and it is also the center of the hypotenuse. Right? The center of the circle is also the center of the hypotenuse. Right? So if the circumradius is 7, then hypotenuse will be 14. Hypotenuse will be 14. Right, this is the circumference. Right. Hypotenuse will be 14, and there is also a very important formula for finding out the in radius when you already know all the sides of a right angle triangle. So that formula is plus b a plus b minus h upon 2 will give you the in radius. So here we already know the value of r, we know the value of h. So here we'll get the value of a plus b. So a plus b will be how much? 2r plus h. 2r plus h is equal to a plus b, equal to a plus b. Right. So r is 2, 2r is 4, and h is 14. So a plus b is equal to how much? 18. A plus b is 18. Okay. So from here we can find out the semi-perimeter. Semi-perimeter will be how much? A plus b plus h by 2. A plus b plus h upon 2. So a plus b is 18, h is 14. So a plus b plus h is 32. 32 upon 2 is 16. Semi-perimeter comes out to be 16. And we know the area of a right angle triangle is also small r into small s. This small r is the in radius and this small s is the semi-perimeter. We already know the values. So small r is 2, s is 16. So the answer is 32 square centimeter. 32 square centimeter. So this is the answer. I hope the question is clear to everyone. So this is also very important formula. I hope you all must have taken note of it. This is a very important formula. It will be helpful in solving a lot of questions. Right. So please note it down. This is a very important formula. Okay. With this we have solved some questions and also looked at the various formulas for calculating the area of a triangle. So in the next video we'll look at some other topic related to triangle as well, but not area. Maybe we'll look at about medians, centroid and orthocenter. Thank you.